Good morning, everyone. I welcome you all to the session 7 of Programmable Logic Controller. In the last session, we have discussed about the architecture of PLC and what are the advantages and disadvantages of PLC. In the present session, let us discuss about the applications of PLC, specifications of PLC, input-output processing, ladder diagrams, and digital logic functions. PLCs are widely used in industries. So it is used in petrochemical, biomedical, distillery, beverage industry, food industries. It is used in continuous bottle filling system, used in batch mixing system like in chemical industry, cement industry, food and paper industries, stage air conditioning system, traffic control, used in radio frequency remote control to control large equipment at a safe distance, car washing, which is an example for process control, portable water purification to disinfect water for drinking, diesel generator control to regulate startup and shutdown. It is used in packaging equipment, various types of vegetable, stretch wrap, shrink wrap, bagging, liquid vitamin dispensers for livestock, that is the regulation of vitamins dispensed in food. Coming to the PLC specification, whenever we plan to buy a PLC, the following parameters have to be considered: necessary input and output capacity, types of input output required, size of memory required, speed and the power required of the CPU and instruction set, manufacturer support and backup. Input output processing. The basic programming used in PLC is ladder programming. There are two methods we use for input output processing. First one is called continuous updating, and the second method is called masked input output copying. So what is continuous updating? Continuous updating involves scanning the input channels as it occurs in the program. Each input point is examined individually and its effect on the program is determined. A built-in delay of 3 milliseconds is there to ensure that only one input is read at a time by the microprocessor. The outputs are latched so that they retain their status until the next update. The second method is masked input output copying. In the previous method, that is in continuous updating, there is a 3 milliseconds delay in reading each input. So the time taken to examine several hundreds of input output points becomes comparatively more. So for rapid execution of the program, CPU copies all inputs and copies their status into the random access memory. As the program is executed, the stored input data is read and logic operations are carried out. At the end of each programming cycle, all outputs are transferred to the RAM. The outputs are latched so that they retain their status until the next updating in masked input-output copying. Coming to the ladder diagram is a special schematic which is mainly used to document industrial control logic system. So the programming in PLC is called a ladder diagram because they resemble a ladder. with two vertical rails L1 and L2, and as many rungs or the horizontal lines is there to control circuits. It has got several horizontal lines to represent the control circuit. A ladder diagram is read from left to right and from top to bottom. Each rung should start with at least one input and end with at least one output. The sequence followed in ladder diagram is: solve the inputs associated with one rung of the ladder program, then solve the logic operations involving those inputs, set or reset the outputs for that rung, move to the next rung and repeat steps 1, 2 and 3. Similarly, you move to the next rung and repeat steps 1, 2 and 3 until the end of the program is reached. The various symbols used in ladder programming are: the first symbol is normally open switch, which closes when there is an input. The second symbol is normally closed switch, which opens when there is an input. The third symbol is the output, which may be a solenoid, lamp, or a motor. The fourth symbol is the counter. The fifth symbol is the timer. And the sixth symbol represents end of a program or special instruction. Now let us discuss the digital logic functions, that is the OR gate. Here the lamp glows if either the contact A or contact B is actuated. So for the lamp to be energized, we have at least one path for current from wire L1 to wire 1. The simple logic OR function is implemented with two contacts and a lamp. The second digital logic function is AND gate. The lamp is energized if both contact A and B are simultaneously actuated. A path of current exists between wire L1 to the lamp or the wire 2 if and only if both switch contacts are closed. Digital logic function for NOT gate. The lamp is energized if the contact is not actuated, and the lamp is de-energized when the contact is actuated. Digital logic function for NAND gate. The lamp is energized if any one of the contact is unactuated. Here we have two normally closed switches placed parallelly. So if any one of the contact is not actuated, then the lamp glows. The lamp will go out if both the contacts are actuated simultaneously. Let us see a video on ladder logic.
And try to understand how to control a process. But before starting to program, let us understand what is a ladder and what is ladder programming. As discussed in previous videos, we know that PLC is a logic controller which has terminals for inputs and outputs. The relations between these inputs and outputs are established via a control logic. The control logic can be programmed using different programming languages. Some of them are FBD, ladder, sequential logic, structured text, etc. Out of this, one of the most commonly used language is ladder logic. It gets its name because the program looks like a ladder with different input-output relations. We can see a ladder logic in front of us. The left and the right lines correspond to power lines. The horizontal lines where the component blocks are placed are called as rungs. Once a ladder logic is written, The PLC processes the code from left to right and top to bottom. Let us try to build a ladder logic for basic gates, that is AND, OR and NOT. We will be using push buttons and LEDs for the same. A physical, discrete input can be mapped to logical inputs in a rung. The value that these discrete devices can take are NC or NO. NC stands for normally closed contact and NO stands for normally open contact. This means that when input is not energized, the states will be the ones that are defined. However, if the input is energized, the states of these contacts change. Let us understand this in the form of animation. Suppose we have connected an open switch to input 1. If we connect it as NO contact in the code, the NO contact becomes NC when we close the switch. Similarly, if we connect an open switch to NC contact, it changes to NO when we close the switch. Understand this concept clearly as it will be used frequently in the next couple of videos. Now, let us build an AND gate using 2 push buttons and a lamp. The ladder logic for AND gate is shown here. We can see that one NO contact for each push button is connected in series. An output lamp is further connected in series. A side note on this: inputs are always connected on the left side of the rung. Inputs can be connected in series or parallel. Outputs are always connected on the rightmost side of the rung, and the outputs can only be connected in parallel. When the rung is complete, one can imagine a current to flow and power gets supplied to the output device. Coming back to our AND gate, we can see that the NO contact turns into NC contact when their corresponding push buttons are pressed. The circuit or the rung will be complete.
On the completion of this session, the students are able to know the applications of PLC, specifications of PLC, input-output processing, ladder diagrams, and digital logic functions. Coming to the multiple choice questions, the first company to build PLC was General Motors, Allen Bradley, Square D, Modicon. The answer is D, Modicon. Which of the following is not a PLC manufacturer? Siemens, Mitsubishi, Microsoft, ABB. The answer is C, Microsoft. To increase the number of inputs and outputs of the PLC, one can use expansion modules. True or false? The answer is A, true. Dash of PLCs can be done in very little time. Programming, installation, commissioning, all of the above. The answer is D, all of the above. PLC can be dash in plant to change the sequence of operation. Only program, only reprogram, programmed and reprogrammed. D, able to give a set point. The answer is C, programmed and reprogrammed. The PLC is used in machine tools, automated assembly equipments, molding and extrusion machines, all of the above. The answer is D, all of the above. Who is known as the father of PLC? Steve Jobs, Bill Gates, Dick Morley, none of these. The answer is C, that is Dick Morley. The programming line known as dash uses in ladder logic for PLC. The programming line known as dash is used in ladder logic for PLC. Wrong, rung, right, none of these. The answer is B, rung. What do you mean by no contact used for input in ladder logic? Normally operative, normally open, not operative, none of these. The answer is B, normally open. What do you mean by NC contact used for input in ladder logic? No contact, normally close, none of these. The answer is B, normally close contact.